Hi, welcome to Redis conference. My name is Vishy Kasar and I work at Apple. And today I'm going to be talking about some of the great security leaps that have happened in Redis 6.0. First, I would like to thank Redis Labs for holding this conference this year in spite of the corona scare. It's absolutely the right thing to do. I also like to thank all the contributors who contributed to the security as well as other areas of Redis 6.0. Here's a quick outline of my talk. I'm going to present motivation on why we need some of these security enhancements in Redis 6.0. Then I'm going to talk about two key features, transport layer security and access control list. So you guys may remember there were a whole bunch of security breaches in 2019. I'm not going to mention any of the company names. However, there were 500 million plus records that were exposed from a social media company, 100 million records that were leaked from a major bank, and 100 million insurance records that were stolen from a real estate agent. We do not want Redis to be implicated in a future security breach. And these days, security is not just between a client and a server on the internet. We have many different components. Client may talk to a load balancer. There'll be a bunch of server instances behind it. Server is talking to database server is talking to cache. So we want no weak links in any of these. End-to-end security is crucial. Otherwise, we'll be sorry. Now let's see how Redis 5.0 handles some of these cases. In Redis 5.0, password is sent in clear over the wire and it can easily be sniffed. If a password is compromised at a given client, changing that password is not very straightforward. The reason is Redis 5.0 just supports one password, and if you change that, then the existing clients will get immediately impacted. And in order to change it, you need to take a downtime on the client side. Managing password that's shared between client and server is a massive operation pain. In Redis 5.0, all users have access to all commands, including the dangerous ones. There has to be at least two sets of users, normal users and admin users, but in Redis 5.0, there is no distinction at all. Also, all users have access to all keys, and this is kind of becomes important when you're running against a shared Redis server. So Redis 6.0 obviously comes to the rescue. It has these two nice features that are going to address various such aspects. Let's dive first into the transport layer security. So it's TLS. It's a successor to Secure Socket Layer, the SSL, that's been used on the web world for many years. It provides two key benefits. It provides encryption over the wire, and it also provides authentication of the client or the server. Few important components of TLS are there's a private key that a given entity holds and does not share. The associated public key is packed with the subject and signed by a certificate authority into something called a certificate. And there's also a list of certificate authorities that a given entity uses. Let's see how this all come together. It's a quick primer on TLS. When client talks to a TLS-enabled server, it sends a SSL hello. On the server side, there is a private key in red and public key in green. There's a list of certificate authorities that server trusts, and server has pre-created a certificate that contains its own subject, its public key, and a certificate authority that signed that certificate. So server sends back the certificate to the client. The very first thing that the client does is check if the CA that signed the server certificate, is it known and is it trusted by the client? If so, then it looks at the subject, verifies that this is a subject that it wants to talk to, and then it then extracts the public key out of the certificate and keeps it for the next step. In the next step, client creates a symmetric key, and it wants to send that symmetric key in a secure fashion to the server, and it does that by encrypting that symmetric key with the server's public key. When it arrives at the server uses its private key to decrypt and then extract the client symmetric key. Now that both client and server have symmetric keys, a SSL session is established, and every communication from that point onwards can be encrypted and decrypted using that symmetric key. All right, this is how the TLS works. And now let's dive into TLS demo for Redis server. So I have pre-created some of the certificates and associated keys. Let me just show them. I have a certificate authority certificate, a client cert, and a server certificate. Let's look at each one of them. Yeah, so the owner for my CA cert is certificate authority and organization is Apple, and the issuer is the same. And this is typically the case for all the root certs. Now let's do the same thing for server cert. So the owner of this certificate has a common name of Redis server, also from the same organization, and the issuer here is the certificate authority that I just showed. And for the client, it is very similar. It has a CN of Redis client, but it is also issued by the same certificate authority. Okay. So we've seen the different certificates involved here. Now we want to start Redis server with specific options in order to enable TLS. Let's go over those options one by one. The very first is what TLS port my server should be listening. And here I say 6379. And I do not want any clear communication on this Redis server. So I mentioned the clear port as 0. The next three options, I provide my server certificate, my server key, and location of my certificate authority certificate. The last option here, TLS auth clients know, is pretty important. By default, Redis server expects the client to present a certificate. But as the first part of our demo, I'm going to turn that option off. So let's run the server. Okay, this is my TLS enabled server. Now, if I try to connect to this TLS enabled server using my normal Redis CLI, I expect this to fail, and it does fail. So how do I make it connect? The very first thing is I'll have to provide, tell the client that, hey, TLS is enabled. Is that alone sufficient? No. We know that when the SSL hello is sent, server is going to send back its certificate, and the client needs a trusted root or CA. So we'll provide that. Now let's see if it's able to connect. Yes, it's able to connect. So we've showed how client can talk to TLS enabled server. Now let's kill the server. I want to now run the server in a mode where it expects client to send the certificate. Let me just show you the config. This is same as before, except where there was, auth required no in the previous config file. In this current config file, we don't see that, and hence client is expected to send its certificate. So let's run the Redis server. With this config. And now, since the client is expected to present its certificate, I expect this specific command to fail now. And it does fail. It says client did not present a certificate. Okay, let's make client run with the right option. In this, I provide client certificate, client key, and as before, the CA cert, and it's able to now connect. Cool. So we demonstrated how client can talk to TLS enabled server, both when the client authentication is required and when it is not required. So that's between the client and server. How about between a master and replica, right? When TLS is enabled. That is possible too. So in order to show that, I'm going to show you a config for a replica. Replica is running in a TLS port 6380. Rest of the options are similar. And I'm going to say this is a replica of localhost running at 6379. And the last option here, the TLS replication, yes, that's what makes it talk to master using TLS. So let's run this. And as you can see, master and replica are already talking, receiving bytes, sending bytes. So the TLS between master and replica are successful. So that kind of ends our TLS demo. Let's get back to our presentation. Now let's go into the next key feature, which is the access control list. It lets you support multiple users and allow multiple passwords for a given user. It can help you limit user to a subset of keys, subset of commands, and it also can limit user to a command category. Command category is basically a category of commands that are related to each other. So instead of giving access to individual commands, you can provide access to the whole list of commands. So how do you use multiple user support through ACL? So ACL has a bunch of subcommands, such as ACL users to list the users. ACL set user is a key command that is used both to create and modify user. ACL delete user for deleting the user, ACL get user to get user details. How do we support multiple passwords through ACL set user? So ACL set user uses control characters to denote which part of the user property that you're dealing with. For example, to add a password, you prefix the password using greater than sign, and you remove a password using less than. If you want to add password using a password hash instead of the clear password, you can use hash sign, and you can remove the password using hash by bang. In a similar way, we can authorize users to allow or disallow commands using plus or minus. And similar thing can be done for command categories using plus @ and minus @. And we can allow access to keys using tilde followed by pattern. And the pattern here is exactly the same as the one used in the keys or scan command. So now let's go into the ACL demo. Let me restart my server. So I can get a list of existing users by or ACL list is telling me that there is a default user. He is currently on. There is no password set on the default user. And tilde star means it has access to all the keys. Plus @all means it has access to all command categories. And this default user has been created just to be backward compatible with Redis 5.0. Now let's go ahead and create a new user. ACL set user U1. I'm going to turn the user on, and I'm going to set a password using the control character greater than and say P1. Now if I do ACL list, it shows me a new user called U1. User is on, and he has a password with a hash of F6 that actually corresponds to P1. And by default, he has been not given access to any commands. All right, so now let's go here. Let's run Redis CLI and see if I can auth using that user, U1 P1. Yes, I'm able to. Now, can I auth using a different password called Q1? No, as expected, that's not a legitimate password. Let's come back here and add a new password called Q1 for the same user. So I'm going to introduce Q1 and do a ACL list. And this time I see two password hashes, one with F6, one with C7. If I go back here, if I do auth U1 Q1, okay, now it's okay. How about I delete the password now? I'll go ahead and say delete the password P1. If I go back here, auth U1 P1, this should actually fail. And it fails as expected. So I come back here. How about I add the password back, but this time using the hash. And we know this is the hash for P1. I'm going to add P1 back, however, this time using hash. And if I do ACL list, I do see it come back. And if I go here, U1 P1, yes. How about we remove the same password, but this time using the password hash? Let's go ahead and use the control character bang. I'm removing the password P1 for the user. Do a ACL list. Single password now. So if I try to do U1 P1, it fails as expected. Cool. We saw how to create new users and how to add and remove passwords, both in clear text as well as using password hash. Now let's turn our focus to what user can do once he is authorized. once he's authenticated. Now let's say auth u1 q1. Now, can the user do any operation such as k1 v1? I expect this to fail because we have not given access to any keys for the user. This user has no permission to run set command or its subcommand. Not only have we not given access to any commands, no keys. All right, let's fix that one by one. Let's go ahead and give access to set and get command for the user. If I now do ACL list, I actually see get and set. If I go back and do set key1 v1, so this time this user has no permission to access one of the keys. He has access to the commands, but he has no access to the keys. So let's fix that. So let's say u1, I want to give user u1 access to any key starting with u1 keys colon star. And if I do ACL list, so I do see now user has access to u1 keys. Let's go back here, set u1 keys k1 v1. Expect this to succeed. Yes, it does. Can I get u1 keys k1? Yes, I can get because I've given access to both get and set. How about if I do l push u1 keys k2 v2? This I expect it to fail because I'm not given access to l push. And just as expected, it fails. Now, this is getting tedious that I had to give permission to individual commands. How about if I have a way to give access to all list related commands? And that's where command category comes into picture. So I'll do ACL cat for category, and that lists all the existing categories such as key space, read, write, and each category has a bunch of commands behind it. And we do see here there's a list category. So I'm curious to know what is contained in that category. Oh, it contains all the list related commands. So I'm going to give access to list category. Way to do that is plus at list and verify that using ACL list. Cool. Now you see list category also listed there. So if I go back now, I'll push u1 keys k2 v2. I should be able to, and then I can do l pop u1 keys k2. Cool. So we showed how we can give access to different commands and different keys using ACL set user. Back to presentation. And here's a quick ACL set user cheat sheet that I've created for you that you can take home. As you can see, there are various functions that you can add and remove using different control characters. For example, password, password hash, keys, command categories. I've given some examples as well as some aliases that help you. So as part of the motivation, I was mentioning what are some of the existing problems in FIO. Now let's see if the Redis 6.0 solved all the security issues. The clear text password sent over TLS cannot be sniffed. Compromised password can easily be changed without incurring a client downtime. As we saw, you can easily add a new password and remove the old password. We can avoid managing the password by using mutual TLS. The reason why this is in a different color is Redis 6.0 is almost there, but not quite, as I'll explain in the next slide. And as we saw, user access to commands can be controlled through ACL, and user access to keys can also be controlled through ACL. So does that mean that Redis 6.0 has resolved all the security issues? Not quite. There are a couple of minor things that are still needed. As we saw in the TLS demo, server is capable of authenticating client. However, there's no way today in Redis 6.0 server to say only authenticate the clients that match a specific subject in the certificate. That minor enhancement is needed. And today, the ACL is tied to the user that you create. But what if mutual TLS is used and the certificate establishes the authentication? So currently there is no support, ACL support for the TLS authenticated user. There's a bit of work needed to marry the ACL and the TLS authenticated user, which will be great. So this is all I had to share today. I would like to thank you very much. Stay safe. Bye now.